Hello, so today I'm doing this weekly contest 17. Let's see the second problem, matrix blocks sum. So we get a matrix, and integer k, you want to return a matrix answer, where each answer value is the sum of all elements in matrix, row, column for I minus k. Between the row between I minus k, so the range basically, and then this range here, and RC is a valid position in the matrix. So we get a matrix and we want to do it like that. The ranges here, it can be 100, the matrix itself length, so all of them are 100. So I think probably like just a brute force should work fine, right? Because doesn't look complicated, because yeah, the bonds don't look complicated. I think one solution would work. So so the answer for one, so we need an answer function that is like, this is let's call them rows, columns for length of matrix, and we are guaranteed that the matrix has at least one row and at least one column. So we can just do this without checking the bounds, and this is for rows, this is for columns, and then this here is that for range of rows, and we need to for each position, so for I in range of rows, and for j in range of columns, we want to say answer at ij is equal to matrix at ij. So it actually needs to be equal to all that range, right? So we will need to say for and then I plus k plus 1, and then similar thing for j, which would be j minus k, j plus k minus 1 plus I j. So k can be really big, so we need to avoid the max. So here we need to say min 0, right? And or max 0 and that, right? And here we need to say min of that and the number of rows, right? We shouldn't go past the number of rows. Actually, yeah, shouldn't go past the number of rows. And then here, similar thing. Should have passed the number of rows or columns, I mean, and then we could do that, and then at the end we could just return answer. Okay, looks way off. So I go through each one of them. It's I j, that's what it is. Index out of range, line 10 here. So one of these didn't actually do what it's supposed to do. So we shouldn't have columns, it should be column minus 1. Well, you know what? We could just do plus 1 here, right? Inside. Okay, so answer ig is the sum of all elements rc. Let me just make this rc so that kind of matches the problem. So L the element R, C for is between I minus K, I plus K, and inclusive, and between J minus K and J plus K. It has to be a belt position, which is why I'm doing this here. Okay, let's try with a simpler example here. So what if we have just, okay, let me just take this, debug it, put up so get something like this, and that would be using this. So that's my solution. It should have been 44, it should have been 12, just like for the first one. So let's see. So the first one right now, so the ranges should be 0 and K is 1, so the range should be I minus 1, so that would be minus 1. That's why it has to be a valid position, but I will say 0, so minus 1 won't be correct. So I'll take the 0's position and we'll go take the min of the 2, so I plus 1, so that would be 1, right? So it should be 0 and 1. So right now it's 0, and then C is same thing, so 0, so it should be 0 and then it should be 1, but C here has a mistake because it should be plus 1 here. Okay, that looks good. Okay, let's try this one. But this is O(n) squared, right? So that would mean 100, 100, 10 to the power of 4 is just with this. With this, it could be 10 to the power of 8. So maybe it won't be that efficient. Let's see. Yeah. Yep, that's what I guessed. Yeah. So maybe, yeah, we don't need to accumulate like the entire thing. We could reuse the previous solution. Okay, so we need a way to make this more efficient, right? So I think here we have the previous solution, right? We do have the previous answer for I minus 1. So maybe we could just reuse, basically for I minus K, we have, but we can't reduce the I plus K, but we have I minus K minus 1, right? So we need to just add, basically just add I minus K, right? So here we could just say, okay, this here would be plus the previous, for the previous I, which is I minus 1, basically this is also if I of course bigger than 0, right? So this would be I minus 1j. I minus 1j, right? Yep, the previous row. And but that one contains the things for column j, so maybe we could do j minus 1. And now here we could just go like, so it's all the way to I plus k minus 1, right? So actually all we need to add is I minus k and I plus k, right? And we also have, so here it's just that plus matrix for if it is valid, right? So if I minus k is bigger than or equal to 0, then we need to add that. So we need to say, okay, plus mat of ij, I minus k, j, no, I think that looks a little bit complicated, more complicated than it should. Maybe we could just do prefix sums, right? Yeah. Yep. That's what we need to do. It's like a square thing. So yeah, it's more of a prefix sum. Yep. Instead, it's a prefix something. So so instead, so we need answer, and then, but before that we need prefix sum, right? And then we need to have something similar for answer, right? And then I think I do have a prefix sum for matrix. And then there is some region, right? So first we need to compute. So I do have that, and then we need to say pretty much this for the prefix sum, right? So this would just compute prefix sum. So this would be tricks, and so this is the first row. And then this would be, okay, let's just call it. Okay. Now, once you get that, you could just return sum of a region, and sum of a region is like just this, right? So let's just define that here. And now, just say something similar. So for the rows it would be, so basically I, J, that's the first. So basically from I minus K to J minus K, right? And then I plus K, J plus K, right? And of course we need to make sure it's within the boundary, so max of 0 and that. Max of 0 and this, and then min. This has to be a valid row, so row is -1 and that, and min of okay, that looks alright. Let's do this and 2. Cool, so that passes. Yeah, cool. Since I'm guaranteeing that I'm passing the right things, I don't think we need to do this. So left and upper are just that. And we don't need that either. So it's just this. What? So we don't need this since we are guaranteed by the condition that this won't happen, so that should still work. And then we probably don't need this left here. We could just say this and remove this portion. That gives a wrong answer. Oh, because for 0 we shouldn't. Yeah, okay. Yeah, got it. For 0 we shouldn't remove it. So basically yeah. Okay, so it should be actually just left. Cool. one thing I want to change for this to be let's see how other people solved it. Okay, so there is definitely a way to make this easier to read, I think. So let me just try to rewrite it in a way that, or maybe just use the solution here. So I think one of the solutions that was here was pretty good. So it's the same as mine. It just computes it in a better way, essentially. So of course we get the rows and columns, so that would be length of matrix and length of matrix 0, and then we do the computation of this prefix sum, right? So this would be prefix sum, right? It's just 0, right? 0 multiplied by number of columns, right? And then so 0 actually 4. I think this is more readable. So 0 4. So we are going to avoid like doing this check here that I did for each for the 0th and 0th column. We're just going to say, okay, let's just add an extra one so that we don't need to check indices. And then range of rows plus 1 here. After that we need to go through in range of rows, right? And something similar in range of columns, so that would be C. And then we say, okay, prefix sum for row plus 1, C plus 1 is going to be equal to the left section. So the left section, so R C plus 1 plus the upper section, which is 1 C, and then minus the area that we added twice, which is R C, right? And then that's the prefix sum, and then we do the regions, which is where the answer comes in. So the answer is the same thing here, so that will be something like this. This is the answer, and we say, okay, we do the same thing, right? So something like this, and then we do something along that line of so the region that we are looking for. Well, for the first row we are looking for max, right? So it's I minus k, right? So we avoid right? And for the first column, same thing, so it's R actually, so I prefer I, right? J. So here it would be I minus k, right? And then for the column it would be 0 and j minus k, right? And after that, for the other region part, which is min of rows, of course, minus 1 and I minus k, and I plus k, and min of columns minus 1 and j plus k. Right, so now that we have both, we can just say, okay, the answer for ij is equal to, well, it's going to be equal to the prefix sum of the region, of the larger one, which is R2, C2, minus the left section, which is prefix sum of, I would say, let me just, I have it drawn here, so it would be the left section, so that would be R1, no, actually it would be C1 certainly, but it would be no, R1, that's the row, and then the column would be, it's R2, the column would be C1. Yep, that's the left section. And then for the upper section, that would be, that we'll need to remove, would be the same column, so certainly C2, but R1. And then the section we removed, the left upper that we removed twice, we need to add it once to make up for that. So that would be essentially R1, C1. Does this match this? C2, R1, C1, R2. Except here, I need to remember that, well, my prefix sums are plus ones, so that will be here. So R2 plus 1 certainly. And then here, it would be C2 plus 1. Yep. And that's pretty much it. You can return answer and try this. What? So my solution looks like, well, we do the prefix sum here. It should be oh, yeah, I know what the problem is. The problem is that here I didn't add the matrix value itself, so I need to add the matrix value at ij. Otherwise nothing will be working. So matrix value left upper, okay. Yeah, there is the extra zeros in the answer. So answer actually should be just cool. Okay, cool. I think that's it for this problem. Yeah, thanks for watching. See you next time.